Okay, my name is Walter Edward Hammond, Hammond, and my job title is adjunct faculty at University of Central Florida. I teach mechanical and aerospace engineering, in particular aerospace. We have a senior design program where we teach graduating students in their last year the principles of design and fabrication, assembly, and flight of an article or deployment of an article, a system that students learn the entire system engineering process from design conception to fabrication to build and deployment of whatever article. It's usually an aircraft like a UAV, unmanned aerial vehicle, or in my case I got 4 teams of rockets that are building rockets this year. Unmanned aerial vehicle is no. Typically we use aircraft because that teaches the students the principles of flight dynamics and control, and that works better for them. It could be a drone. We do have electric powered aircraft we can use, but we want them to exercise the domain of aerospace engineering and flight dynamics and aerodynamics. And so we try to stimulate them to think about technical fields. It doesn't have to be aerospace engineering. It could be mechanical engineering. It could be electrical engineering or civil even. But we get them to start thinking about a technical career versus a career that's non-scientific. Well, many jobs. It's a very broad scope. Interestingly, Central Florida, and particularly the Cape, but Central Florida also has many aerospace jobs. In total, we've got, I would estimate, over 20,000 positions that involve aerospace and mechanical. Actually, if you broaden it to mechanical in all its domains, you're talking 30 or 40,000 jobs. Well, in engineering in general, engineers many are introverted. I encounter some introverted personalities that inspire, others not so. But an engineer, typically, he looks at his shoes when he's in an interview situation. If he's if he's an extroverted engineer, he's looking at the other person's shoes. And that's a typical hallmark of an aerospace engineer. So typically they're studious, they're serious, they're dedicated to the profession, and they learn this as they progress through the career field. Challenging assignments challenge them, and they, if they have aspirations, they can pursue a management position later on. Typically they don't start in management, or they can continue on in a technical field and progress up the ranks that way. Well, I use myself as an example. I did not know what I was going to major in. I just thought it'd be engineering. I thought civil engineering as a high school senior, but then when I went to the university, you don't generally start with aerospace engineering courses or mechanical. You start with general courses for technical fields or engineering fields. And then I really liked the aerospace. It just attracted me. So you get into it. As you get into it and learn more, you learn which pathway you want to pursue. There are a few that know early on what they want to be. That's the exception. Well, I'll use myself as another example. I've been in aerospace. I joined the Air Force and pursued a military career. I stayed in the Air Force Reserves for 30 years, and then I pursued, while doing that, I served in the Air National Guard too for a span of time. Then I pursued an engineering career in consonance with Air Force career, and then I became an author. I have authored 6 books, and now I'm a professor at UCF, so that's like 4 careers, and I'm still groping. I'm trying to learn my way. I don't see a 5th possibility, but who knows at my age. And in fact, my students at UCF they communicate very well. That's a key skill. You have to learn to communicate unless you're isolated as a scientist in a cubicle and don't want to talk to anybody. That's again an exception. Most engineers have to network and work together as a team. You have to learn that. You have to learn communication skills, how to give and take, how to handle minority opinions, which sometimes could be right, how to brainstorm, and basically how to work as a team and handle the project and take a systems view. Students usually don't have a systems view when they graduate, and we try to tell them, look, it's a whole system you're working in as part of a system. Yeah, problem solving, that's key. You got to focus on the problem. In engineering, you often go up rat hole, different paths that are dead ends. For instance, right now I'm working on trying to get us out of rockets. I'm a rocket scientist, but I see a deficiency in rockets. We've been in rockets since 1926 when Robert Goddard invented the rocket. And it's time for us to progress, but there's a lot of dead ends. It's hard to get out of. You pursue a dead end, if that doesn't work, you try another path. And teamwork, again, some engineers, the best in, well, no, not the, I should say a good hallmark of a good engineer is to be able to work as a team and not isolated by themselves.